Do you know how to set up the noise analysis in Spice? Do you know how to set up the distortion analysis in Spice? Do you know how to set up the sensitivity analysis in Spice? Stay tuned till the end of the video to know all the answers. Hey guys, welcome back. In today's episode, we are going to discuss the below topics. First, we will talk about the noise analysis, which is very closely resembled to the AC analysis. Next, we will dive into the distortion analysis. Again, you will find some similarity here with the AC. And finally, we will conclude today's episode as well as the Spice series with the sensitivity analysis. That's the menu for today. Without any further delay, let's begin. In last episode, we have started the simulation control. And this episode, we will conclude with 3 different statements as we have discussed in the menu page. So without any further delay, let's begin. The first topic is the noise analysis, which is the .noise keyword. And let us see some details about. Noise analysis is run hand in hand with an AC analysis. It calculates the input and output noise of a circuit. The output noise at a specified output node is the RMS sum of the noise generated by active and passive elements present in the circuits. That is the summary of the noise analysis, the theory behind the noise analysis. And now let us look into the command details. So this is the command. Now let me highlight. So this is .noise is first. Then we have a V, then output node and a reference node. And we have SRC, and then we have 3 types of analysis, which is very similar to the AC analysis, the decade, linear and octave. And we have number of points, then F start, that is the starting frequency, and F stop, that is the final frequency. And we have points per summary. That is another additional point that you have not seen in the AC. Here you will see it when we are going through the example in the next slide. Output node is the node at which the total output noise is desired. So this one we are talking about. If ref is specified, then the noise voltage, that is V output node minus V ref, this value is calculated. So this is the voltage between the output node and the reference voltage that we have given. By default, the ref is assumed to be ground, basically the ground of a circuit. And also we can specify some reference voltage here also, or the reference node rather. SRC is the name of the independent source to which the input noise is referred. So it is the source of the noise. PTS, F start and F stop are the AC type parameters that we have already seen, and these specify the frequency range over which the plots are desired. So this is the starting to the ending frequency, and these are the number of points that we want in our graph or in the data, whatever is applicable. PTS per summary is an optional integer. If it is specified, the noise contribution to each noise generator is produced every PTS per summary frequency points. PTS per summary is an optional integer. If it is specified, the noise contributions of each noise generator is produced every PTS per summary frequency points. So that is the detail of the command of the .noise. And now let us move on to the next slide to see some example. So the first example here is this one. So here we have noise, then we have V5, then V in, then decade, and 10 is the number of points, then starting frequency and ending frequency. So this is the first type, and you can see it's very similar to the AC, right? And here you can see these 2 voltages, right? V5 and V in. So these are 2 things that you can relate with the noise command. Now let us see the next one, where we also have the last parameter, which we do not see here. So here again it is the noise command. Then we have V53 instead of V5. Then we have V1. Then we have oct, that is octave type of analysis. Then we have number of points is 8, starting frequency, ending frequency, and it is the summary points that we have already discussed in last slide. So these are 2 typical example of the noise analysis. And here we are done with the noise analysis. So let's move on to the next slide. The distortion analysis, the distinct. So here it is explicitly said that this is used with the hand in hand in the AC analysis. The .disto line does a small signal distortion analysis of the circuit. The Spice reports the distortion measures at specified passive load component. Load components generally are the C, L, etc., right? Or the R, okay? So these are load components and these are passive in nature. Now the format is .disto, then we again have the digate, then ND, F start, F stop and F2 over F1. We will see it later. Up to this you can see this is resembling with the AC analysis format. We also have the octave and we have the linear. Again here these three are number of points and these are very common. That is the starting frequency and the ending frequency. And we will see what is this later on. Let us see some example. Here the distortion and we have decade type of analysis. Number of points is 10. Starting frequency is 1 kilohertz and the ending frequency is 100 megahertz. So this next example is we have disto and then we have decade type of analysis, again 10 points and 1 kilohertz to 100 megahertz, and we have F2 over F is means this part as the value of 0.9. So these are two type of examples. Now here it could be octave, it could be linear, and the number of points can vary, starting frequency can vary, and F2 over F1 also can vary. So we are done with this slide. So let's move on to the next slide. We continue with the distortion analysis details. Now here is the syntax. Without optional parameter F2 over F1, the distortion does a harmonic analysis. So this is a type of analysis that is performed without the F2 over F1, which is a harmonic analysis. In such scenario, analysis distortion in the circuit using only a single input frequency F1, which is swept as specified by arguments of the disto command exactly as the AC command. So here we have the very similarity with the .AC analysis. If the optional F2 over F1 parameter is specified, it should be a real number between and not equal to 0.0 and 1.0. So basically this is a range of this parameter. In this case, the disto does a spectral analysis. That means without the F2 over F1, it does harmonic analysis, and with the F2 over F1 parameter within this range, that is the expected range, it does the spectral analysis. So these two type of analysis we can perform with and without the F2 over F1 parameter. ngSpice supports distortion analysis only for diodes, BJT, JFET, MOSFETs, and we have the corresponding levels here. MESFET. So ngSpice has this capability, but it can perform the distortion analysis over a limited number of elements, and these elements are listed here. So we are done talking about the distortion analysis. Now let's move on to the next slide. Here we talk about the sensitivity analysis. Sensitivity analysis is a model that determines how target variables are affected based on changes for a given variable. So this is how we analyze the sensitivity. These are typically what if then scenarios. So in Spice, if we have to do the what if then analysis, we take the help of the sensitivity analysis. It is a way to predict the outcome of a distortion given a certain range of variables. It is a way to predict the outcome of a decision given a certain range of variables. So with respect to certain range of variables, we conclude something. Is sense, then outward, and then we have the sense, then outward, then AC, then we have decade, then ND, then F start, then F stop. And again we have two other formats, that is for octave and linear. We have that, and you can see rest of the things are very similar. That is, we have F start, F stop, right? And we have number of points here, and we have type of analysis, decade, octave or linear, right? And this is the outward. The sensitivity of outward to all non-zero device parameters is calculated when the sense analysis is specified. Generally, we have a lot of device parameters when we have a model for a device, right? Based on them, we can do the sensitivity analysis. Outward is a circuit variable, that is node voltage, voltage source, branch current, etc. The first form calculates the sensitivity of DC operating point value of outward. We are talking about this. The second form calculates the sensitivity of the AC values of the outward. So this is for DC, this one, and rest of the things are for AC. We have done talking on the sense. Now let us see some example of the sensitivity analysis. Here goes our example. First one, sense, then V1, out. So this is a kind of DC, right? As we have spoken already. And then we have the sense, then B out, then AC, then we have decade type of analysis, number of points 10, starting frequency is 100, and the final frequency is 100K. So this way, we have the sensitivity analysis in DC format, that is the DC sensitivity as well as the AC sensitivity analysis. That is sense I VT test. Again, this is for the current analysis and this is for DC. We have reached to the end of this episode. And thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislikes, put that as in comments in the comment section down below. And bye for today.